Ryan, I thought I saw that. All right, there's 3 different assignments I need y'all to find in your binder and have out. So if you'd please do that during the minute of silence, I'd appreciate it.
Good morning, Fayetteville. It is Thursday, September 5th, 2024. Please join me for a minute of silence. Thank you very much. Will you please stand as you are able for the pledge? To the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Have a great day.
Okay, good morning, guys. We've got really 3 big things to check off our list today. I need to give you a chance to ask some questions from the assignment you were working on last class. That's going to be number 12. I need to give you time to finish up the test review because I did ask you to do some of it. That would be the second thing. And then the third thing is I need to make sure that I help you with whatever part of the test review that you might be struggling for. So we do have our first assessment next class. So with you guys being a B-Day, sometimes you get less than normal time, sometimes you get more than normal time. This is one of those times you're going to get more time because tomorrow is an A-Day, so I won't see you again until next Tuesday. Sometimes I see you guys on Thursday and then I'll see you again on Friday, so sometimes you don't have as much preparation time. But since the weekend is between our classes, you've got some extra time here. One thing I do want to remind you, it's up on the agenda, but a reminder about late work since we are coming up to our first unit assessment. So if you have any incomplete work, any work that you didn't finish and got half credit on, if you want to get some of those points back, half of those points back, you have to do that, and I have to have it before we start the quiz next class, which will be at the start of class. So you can turn those into Google Classroom, or you can just plan on giving me the hard copy. I will also be asking for several of these assignments I really could have taken up assignment 11 and 12 from you today because those should have been finished. But there's always a chance. I do my best to grade them, put them in the grade book, and get them back to you the same day. But there's always some times where, just depending on how many questions y'all have, how much help you need, I can't do that. And I don't want to take those assignments from you today, not get them back to you, and then you don't have them to look over to study if you felt like you needed to. So I'll be asking for 11, 12, and 13 before we start the quiz on Tuesday of next week. Those are all also opened up in Google Classroom if you'd like to turn those in early. So with our first quiz here, this will be our first major grade. I call this, did I mention the difference to me, at least between the quiz and the test? Did I mention that in this class? Okay, they're basically the same. It's just that this quiz will go in as a 20-point major grade, whereas most of our, what I would consider a test, go in as 50 points. But temporarily, on Tuesday, it's going to be your only major grade, so temporarily it's going to be 60% of your grade. By the end of the semester, that 20%, or that 20-point assessment's not going to weigh near as much. But most of our assessments are 50 points. This one just happens to be 20 points, just based on how important it is compared to the other stuff that we do. So that's kind of our plan for today. So if you don't have any questions on assignment 12 that you worked on / finished up last class, then you can go ahead and pick up wherever you left off on the test review, and you can keep working on it for a few minutes. And then once I exhaust all of the questions from assignment 12, I'll take whatever questions you have ready from the test review, and then I will alternate between giving you time to work and giving you time to ask questions. Now, the test review does have the solutions up on the website now. I think there still might be one typo or mistake on here. I tried to do this whole thing in about 15 minutes yesterday before school. So just rushing like that, I probably made a mistake or two. So if you disagree with something on the test review and you're pretty sure you're right, you should go ahead and ask. It could be my fault. And if it's you that's off, then you need to get it corrected today anyway. Okay, so if you needed to ask anything about assignment 12, this is your chance. Assignment 12. Yeah.
On the test, when we were talking about types of discontinuities, do you care whether we say vertical asymptote or infinite or removable?
Yes.
'Cause
A hole is describing the graph. A vertical asymptote is describing the graph. If it's a calculus question, it's 99% of the time it's going to be asking about discontinuities. Those are ways to describe the graph. Those are not discontinuity types.
Okay.
You need to say removable discontinuity if it's because there's a hole there. You need to say infinite discontinuity if it's because there's a vertical asymptote there. And if the limits aren't equal at a point, you could say it's a jump discontinuity. Those are the three that you need to know. There are other types of discontinuities, but those are the only three that shows up on the AP exam. So therefore, that would be the only three I throw at you. Any others from this assignment? Okay. Then, again, last time I did give you the test review, and I told you did not have to have it finished when I saw you, but I strongly suggested that you do the amount proportional to how prepared you were for the quiz. Such as, if you felt really prepared for the quiz and felt like you could get an A or B on it, last time I saw you on Tuesday, it's fine if you did less of the review. If you felt like you're getting concerned, you should have done most of the review. That way you know more of the questions you have. That means you can ask those questions more directly, and it means you need to spend less time finishing up and make sure that you can get that achieved while you're here. So, I realize you don't know all the questions that you're going to have on here, but since you should have done some of this, is there some of these questions that you know you need help with that we can just go ahead and address right away? There's no point in waiting if you already know you need to ask. Yeah.
Can you go over number 23, please?
Question 23. I will. Okay, so now I can't promise to do this as the year goes on, but honestly at the beginning of the year, we don't have a lot of good FRQs to give to you. So I plan on your quiz being some multiple choice, some fill in the blank, and one FRQ. Most of our quizzes, half of the points come from FRQs and half the points come from the other questions, because that's how your AP exam does it. So we try to model it so you're used to that. Since this first assessment, there's never been a free response question that's all about limits and continuity. The parts of them can be about limits and continuity, but there's never a free response that's entirely about those. So to try to balance you preparing, trying to give you something that's actually achievable, but actually having to put in some work, you can see I will make sure that your FRQ is like one of these practice FRQs. So notice 22 and all of its parts, and question 23 and its 2 parts. Your FRQ could look like question 22, it could look like 23, or it could look like parts of 22 and parts of 23. So again, I can't always narrow that down for you, but since it's the start of the year and there's not good specific FRQs anyway, I can at least give you that hint. Okay, so if you need help with question 23, go ahead and follow along with me. If you don't know if you need help with 23, you should probably try it before you see what we did. I will record it, it'll be on the website. So if you haven't worked it yet and you work it later and you decide you need help later, you can still get help later. Okay, so by far the biggest part of this is part A. Part B should only take us about 10 seconds, but we've got to do part A first anyway. So we're supposed to find the values of A and B that make this continuous. So notice we've got a piecewise function that has A's and B's all over the place. But A and B are just going to be numbers. So in the end, A is some number, B is some number. That's what we're aiming for here. And you have to realize that if A and B were just numbers, this is a polynomial, so it's continuous. This is a linear function, which is continuous. And this is a linear function, which is continuous. All 3 of these are continuous. But just because each part is continuous, if this piece is not handing off to this piece at this time, and or if this piece is not handing off to this piece at this time, then they're not going to all 3 be connected, and they're not going to be continuous everywhere. So really what you need to do is, and if I want these 2 to be the same, I'll set them equal to each other. But you need to realize I could care less about this guy's y values and I could care less about this guy's y values, except at this time when x equals 2, when it stops being this function and starts being this function. So as soon as you plug in 2 for x, you get an equation that has a's and b's in it. So you can clean this up a little bit. You could subtract 2 a's from both sides. You could subtract a b from both sides. You could subtract a 2 over if you wanted to. You could divide everything by 2. I don't know. You could do a lot with that. It just kind of depends. But the point is, simply setting the top part of the piecewise function equal to the middle part of the piecewise function at x equals 2 isn't enough to figure out how big a and b have to be. But we have one more thing going for us. I also need this and this to be the same y value at this time to make sure that they're connected. So I can also say middle piece is equal to bottom piece. And again, I really only care that this is happening at one specific time. What time is that? Good, at 5. When it stops being this one and starts being this one, I've got to make sure they're connected. And then as soon as you plug in 5 for x, once again, you get a different statement in terms of a's and b's. Again, you could at least combine like terms, I guess. least combine your A's or something. But once again, you get a second statement in terms of A's and B's. By itself is not enough. But now luckily this is not something that I see on the AP exam a lot, but like I've warned you, calculus will randomly throw out anything you've ever seen. Anything from Algebra 1, formulas from geometry, unit circle from pre-calculus, anything you've ever seen is technically fair game. And in this, you started solving these a long time ago, back in maybe even pre-algebra, but Algebra 1 for sure. This is what you call a system of equations. I have two unknowns, A and B, but I have two equations. So you could solve one of these for A or B, this one for A or B, or this for A or B. This one's already solved for B. So I'm going to do the substitution method. If I go plug this in place of B, it gives me an equation that only has A's in it. Which is enough information to finish off and let me figure out how big A is. And then once you know how big A is, there's several different places you could plug it in to solve for B. I'll just plug it in here. This would be 2 minus B is supposed to be -1. So it looks like B should be 3. So I'm not saying that you guys are going to hit the ground running solving system of equations, but in theory, College Board knows you've learned solving system of equations in the past, and so if and when they want to throw that at you on the AP exam, technically that is fair game. So are you okay with those two parts? Okay. Now the second part of this question, again, this part's a lot quicker. So evaluate the limit as x approaches 3. So you should be looking at these restrictions. This is when x is less than or equal to 2. This is when x is greater than or equal to 5. Neither one of those have anything to do with 3, but between 2 and 5 does have to do with 3. So we're trying to plug 3 into this, but we don't need to call it ax plus b anymore because we know what a and b are. So if I try to direct substitute 3 into this, I get 2 times 3 plus 3, which is 9. So the limit as x approaches 3 would be 9 for that question. Now, I would say most of you guys don't know how to graph piecewise functions or inequality stuff in your calculator. But if you do know how to do that, you could throw these two values in, graph this part here, this part here, this part here in your calculator, and you would see all three of those pieces are perfectly connected. Okay, so that was a great question to ask. Does anybody else, now that the whole thing's up there, does anybody have a deeper question? Anything I went over too fast? Anything about 23 you would like to ask? Okay. So there's a chance part of your FRQ will ask you to do something like this. So make sure that you know the process, and if you miss that the first time, you should probably try it again. Make sure that you can do it. Yeah.
So number 5, there's a question so the limit you're given only fits with one thing, so would you only find like the limit for that problem? Or the
Yes.
answer is-
Yeah.
Okay.
When you say just, are you referring to the left and the right?
Yeah, the left and the right.
Okay. Well, technically the left would get plugged into the bottom and the right gets plugged into the
Yeah.
bottom, but if you're plugging the same thing into the same thing, you're going to get the same thing.
Yeah.
So yeah, it's kind of silly to think of plugging it in twice, but
How do I find the answer for this one? Because this isn't like really like a standard algebra.
number 5?
Yeah, because it's x3 to the second power, that would be 9, ln3, so it'd be ln3 is 9.
9 times the natural log of 3. Yep.
Oh, you don't have to simplify it.
I mean, there's not much you can do. Because this is a logarithm, you could bring the 9 up if you wanted to. And I guess if you know what 3 to the 9th power is, I guess we could change that. But 3 to the 9th power is going to be humongous. Yeah. 19,683. I mean, technically all three of these things say the same, but I would expect a multiple choice question to probably stop there. Yeah, especially in the next unit, you guys are going to get frustrated sometimes about how much do I need to simplify, because I can't give you a definite answer. If you're talking about free responses, free response questions, you don't have to do any arithmetic. This to this to this is all considered arithmetic. If it's correct, any one of those 3 answers would give you the points on a free response. But on a multiple choice, they might stop here. They may choose to do a logarithm property. If they give you a calculator, I guess they could expect you to know 3 to the 9th. How much you have to simplify on multiple choice questions just depends on the question. So that's not too big of a deal with limits, but in our second unit, it is kind of a pain, because sometimes you can simplify 4 steps, and sometimes you have to, sometimes you don't, and it's not always clear cut. But I guess that's a problem for next week. Okay, somebody else have another question from the test review ready to go? Okay, let me give you, I'm going to set a 10-minute timer here, so try to get a few more questions done. Again, the answers are on the website, so you really probably should be checking those on your Chromebook as you get to them. That way if something's wrong, you figure out it's wrong and you get your questions answered here. Also, you need to make sure you get all your questions answered today, because just a heads up, I do not take questions on quiz or test day, and that's not me trying to be mean to you. It's me trying to get you guys to not procrastinate. And if I let you ask a question or two, even if it's just a quick question or two, I have to open that up to everybody, and then that could be 30 or 40 minutes later, and then we may not have time to do the test. So you'll need to make sure you get your questions answered while you're here today. I do not take quick questions right before the test. Okay. So again, I'll shut up here, give you about 9 minutes, and then I'll offer to help out again. Oh, I guess one piece of encouragement I can give you guys as well. I don't have it there. But I did put on our class website near the top. I'll just pull that up. One of the things near the top of our class website this year is this breakdown of your AP exam. So, for the multiple choice, they don't share the free response. But for multiple choice, approximately 10 to 12% of the points on your AP exam come from this one unit. So, in theory, knowing this stuff really well should set you up to get about 10 to 12% on the AP exam at the end of the year. So, it's only been a couple weeks, but again, it's still a good chunk of what they're expecting out of you. So.
5 plus square root of 5 can be simplified?
Well, you could say you have 2 square roots of 5. That's all you could do, though. Just one more minute.
Would just be square root of 5 plus square root of 5?
Or 2 square roots of 5. Just like x plus x would be 2x. Square root of 5 plus the square root of 5 would be 2 square roots of 5. Okay, let me interject here and offer to help out with another round of questions. Okay, so what have you tried now that you realize you need some help on? Yeah.
Sorry, this is just a quick question. On number 4, it
Uh-huh.
says the answer is 7 minus 1/2, but wouldn't cosine of 2 pi over 3 be negative 1/2? So it'd be 7 minus negative 1/2?
You are correct, yes.
Okay.
But the answer to the question is still does not exist, so.
For number 4?
Because the limit from the left is only 6, and the limit from the right is 7.5.
Okay.
If the limit from the left doesn't equal the limit from the right, then it doesn't exist.
Okay, yeah.
But you're correct on that other part. I'll update that later today. Any others ready? Feel like maybe we should have just quizzed today. That's okay. Okay, I'll give you, let's say 15 minutes this time. Now, just a heads up too, in case I don't think to say it at the end of class, but lots of these questions already have videos on the website if you haven't gone there and looked yet, just from yesterday. So, I mean, I don't mind if you access them during class if you have wired headphones, because you're not supposed to have earbuds. But they're also available, I guess, outside of class. And there's 4, 5, 6, 7, 8, 9, 10. There's 12 of those already worked out. So there's a good chance if that's what my other class asked about yesterday, it's a good chance those are some of the same ones you might want help with. So not anything you have to utilize this second, but it could be helpful to you in your studying.
Can you look at number 10, please?
Number 10. Between which of the two following values would this equation have a solution? So to me, this is talking about intermediate value theorem, and I gave you a little bit of a hint here by putting these questions together. So intermediate value theorem says that if it's continuous, which this is a polynomial, and polynomials are always continuous, it's going to hit all the y values between the starting y value and the ending y value. Now, when I look at this, I have no idea. These are x values. So you need to take a minute and say, well, when x is -2, solve for y. So you're going to have to plug that in here. And just to speed that up a little bit, I think I've done most of these. F of -2 should come out to be -34, -45. So that's its starting y value. Its ending y value is going to be when x is -1. So if you plug -1 into this, it comes out to be -19. So if he starts at a y value of -45 and ends at a y value of -19, does it ever have to equal 0?
No.
Right. IVT guarantees it hits everything in between these, but 0 is not in between those. So it might, but it's not guaranteed. It's not a must. Okay, so to do part B, and unfortunately you just have to do this until you stumble upon the right one. F of 0 is going to give you the starting y value. F of 1 is going to give you the ending y value. Plug in 0 into this, get -11. Plug 1 into it, you get -3. So if you start at a y value of -11 and end at a y value of -3, because this is continuous, I know it hits all of those y values at least once. That's what the IVT says, but that's not 0. No guarantee that that's 0. So got to keep going. This time starts at f of -1, which I have that to be -19, and then f of 0, which I'd already done, -11. Does that ever have to be 0?
No.
Okay, so if I was pressed for time on the test, it seems like process of elimination means this should be D. But also, I'd put a star by it, and then if I had extra time, I'd come back and actually finish it and make sure that it worked, and I just didn't make a mistake there. So f of 1, I already have from earlier. I did that over here. F of 2, you plug 2 in all of that, you get 23. And then here's this special relationship. It's going from below the x-axis to above the x-axis. So at some time there, it's got to cross 0 at least once. So that's what you got to do. Unfortunately, you can't just work it in a way and then pick out the right answers. You got to do guess and check. Okay, is anybody else going to ask about 10 while it's up there? Okay, I was going to wait 15 minutes, but it has already been 11 minutes, so I'll go ahead and just take questions now. Others that you found and want help on? Yep.
14.
Question 14. Okay, so 14 is asking for two things. Do the limit as x approaches infinity of f of x, and it wants us to think about the limit as x approaches negative infinity of f of x. Well, first off, it helps if you realize that this is referred to as an infinite limit. Okay, so it helps if you realize this is an infinite limit, which means the limit's either approaching infinity and or negative infinity. And there's two ways you have to work these questions. If this is a great big fraction, meaning this is a rational function, you can just apply horizontal asymptote rules to it. If it's not that, you have to try to physically plug in infinity, physically plug in negative infinity, and you have to try to map out what you think is going on with the function and do function analysis on this. But one thing that would maybe help here, there's nothing that says this has to be in standard order. I know you guys like the biggest exponent first, and then the next biggest, and then the next biggest, but that doesn't mean the questions have to be posed to you in that way. So if you like it that way, you need to rearrange the numerator. Then you can see that the degrees are equal, which means these two things are basically growing at the same rate. But when the degrees are equal, the horizontal asymptote comes from -5/2. And what a horizontal asymptote is, as the y value it approaches as x goes to the far left of the graph, and it's telling you what the y value it approaches as x goes to the far right of the graph. So, oops. Both of those questions are exactly the same work. And again, what prompted me to even think about horizontal asymptote rules was the limit as x approaches infinity and or the limit as x approaches negative infinity. If you don't think of horizontal asymptotes, you're going to miss most, if not all of those. So, okay. Still willing to work out some more if you've got them. Okay, go ahead and keep going then. Looks like we've got about 45 minutes, so still a ton of time. Obviously, if you're finished and you've checked your answers, what you need to do mentally is try to identify the 2 or 3 things that you would be most worried about. Maybe look at those questions a second time. Maybe even force yourself to practice those on a separate sheet of paper a second time. You certainly don't have to do the whole review a second time, but I think it would be beneficial if you practice the questions you struggled with the second time. But that is just my opinion. I will also add that when I make copies, I do try to always make a couple of extra because I know sometimes people forget them and stuff. So this assignment 13, I know there's probably a few of you that would like a second copy. Some of you even will do the whole thing again, and that's great. You don't have to do that for me. But if you do want that, I always put my extra copies over here. There's a bin that says Calculus AB handout. You just need to know this is assignment 13. There's a tab here for assignment 13. And I've still got 10 or 15 of them. So if you want one, you're welcome to help yourself to one. And any of the other assignments as well, you're welcome to. Most of those things just get thrown away and recycled at the beginning of next year, so I'd rather you get some use out of them. about any of them? Okay.
For this one, square root,
Yeah, not exactly, but you're really only worried about the biggest stuff here, so yeah, kind of. So the square root of x squared would be like an x. But you're sure the degree of the numerator is bigger than the degree of the denominator. So that's what it's supposed to, that's all that you need to know. Do y'all have something I can look at and help with over here? No? Is that okay? Okay. Sure. The problem is, now this isn't your fault, that's a cube, yeah, you probably got it there. Yeah. Yeah, since it's cube, you can't just plug that.
If it was square.
Sure. But that's also because it says equal 0. If it said equal 5, you would need to make sure you subtracted it over. But yeah, that would be fine as long as it's quadratic. You doing okay?
Mm-hmm.
You didn't need any help from what you missed last time?
No. Thank you.
Boys, you got anything I can help with?
this one.
You don't, you just have to estimate. So like if you're wanting to know -4 from the left, well here's -4. So here's just a tiny, tiny, tiny bit to the left. That y value looks like it's probably what? Super. Okay, so if this is at 2/3 and it's almost -4, you can, your best estimate would be to say it's 2/3. It's not gonna magically be 27, you know, nobody's gonna be able to figure that out. Is it the same value as h of 1? So I need to see what you got for h of 1. Okay, doesn't exist. I would need to see your limit. I think you're doing that here, but you really should say that you're doing the limit out front. And that cancels. I don't remember if the 1/2's right, but yeah. If the point's not there and the limit's a half, those are definitely not the same thing. So the only thing I would add is when you're talking doing limit work here, you need to squeeze in that limit. Okay, guys, what about y'all? Anything I can get a quick refresher on? Y'all found anything else I can help with right now?
No, that's
Oh, you're good. Found anything else yet, Lynn? Okay, so I'll keep bugging you guys a couple more times for questions, but you still got about almost 40 minutes, so. Again, in theory, you should finish up the review. You should have checked your answers. You should know which ones you struggled with, and you should have time to get those questions answered today.
For this one,
Mhm.
I was wondering, because the way I did it was like find this one and then find this one and multiply them together, but is it because the f is part of the limit that you just take the limit into g and then find it here?
Yeah, so you gotta do this, you gotta think of this in two steps. If you're doing the limit of a function with plugged into another function, you really just do the limit one time, the limit of the inside part, and that's where I got -2, but then you have to plug that into the outside part. So f of -2 is where I got the final answer.
okay.
So you gotta do two steps, limit of the inside part, and then plug it into the outside part as a point.
I just got a bit confused because on the other questions one was like function times function would be limit. But
Yes, yes.
plug it.
If it was times, you would just do both and then multiply them. But this isn't f times g, it's f of g, so that's the difference.
Thank you.
That's the one property that's not very intuitive. And of course, this test review is not like comprehensive or anything. I just try to pick out the stuff that I think is most likely to get you to think about the things you need to, so. Like, I don't know if there's explicitly a question on limits where you have to do the adding property, but that works out like how you would expect. So if you need to practice that specifically, you probably need to go back to that worksheet. You may also notice on the review, this part is optional, but I do try to section these things off to remind you some of the properties or some of the question types. So I'll do that with a little bullet point. And I like these little blanks out front. Again, it's completely optional. But if I was working this and I did these questions 15 and 16, and I've looked over assignment 10 in my binder, if I feel like this is a skill I'm ready for on the quiz test, whatever you want to call it, I just put a check there so that when I go back and study it later, I know I don't need to look at this. I'm pretty sure I feel good about that. But if I don't check off this one, that's my reminder when I look back at this later. That's one that I wasn't feeling 100% confident on, so maybe I need to look at those again. So to me, I just like to check the sections off as a way to narrow down my focus in studying, but that's just completely optional.
Would this be correct?
Okay, but I didn't see where you used the definition. How do you know that that's a problem? You should either be telling me that the point doesn't exist there,
Oh,
you should be showing me that the limit doesn't exist there, or you should be showing me the point's not equal to the limit. Okay, how do you know? What is f of -3?
-3 is 5.
Okay, so put that below it. Okay, what was the limit?
Equal 0.
Okay, you go, perfect. So now you're showing me what you think this is, you're showing me what you think this is, you're using the part of the definition to explain why you think the answer is no. It's perfect.
Okay, I've been trying 21B for a while, and I'm
Mhm.
still confused because it's factored like this in the video.
Yeah, I'm sorry, I think that might be my fault. So I think what happened on this one, is it a longer video?
It's good.
Yeah, so I think, maybe fast forward a little bit, I think I realized after a minute that I factored it, yeah. And that's the problem, if you factor it wrong, then you hit this wall and you're like, wait, I don't even know how to do it.
Yeah, so H of 9 would be 1.
Zero over zero. Well, the limit of 0 over 0 could be anything. 0 over 0 just tells you that the graph's gonna have a hole in it. And if it has a hole in it, it's not equal to anything. So you should say the point.
Okay. So, okay, and then we just find the limit of
Yeah, I just do the limit as x approaches 1 of the function. So I would write the function part out here, factor it, of course factor it correctly, otherwise you put it on the right hole. I would not get something to cancel, plug it in, and you get like a half or something. But at the end of it, the point doesn't exist, the limit's like a half, those two things are not the same. So that's what it says. Now, with a few of these practice questions, you may not have even noticed, but some of these questions have like point values on them that I put on here for practice. And that's because I took them from some other teacher's test that they give in the first unit. So, I don't know if that means anything to you, but like question 21 accidentally has point values on it. So you can see there is a teacher that puts that on their test somewhere, and I was just giving it to you as practice. don't know for sure, but the table is just an estimate. But you can see x is pretty big here. And it looks like it's getting close to a y value of, so that's my guess. I mean, it might be going to 20, but nobody would have any way to know that, so. Pretty good estimate. So since I saw this, I wanted to do horizontal asymptote rules if possible. So I knew the degree of this was 1, and if you think of taking the square root of this, it's like it has degree 1. So when the degrees are equal, you put leading coefficient -3 over leading coefficient 1, and that's where I got -3. Or positive. Not 100% of the time, but most of the time. You might look back at the infinite limit worksheet. Sometimes all you can do is just plug it in and try to figure out what's going on with the function. Well, h of 2, you just plug in 2 into this and you get a number. And then for the limit, I like to rewrite it down here. So I would say the limit as x approaches 2 of all of this. And to do a limit question, you should do direct substitution. So when you plug 2 into this, isn't that the exact same work as plugging 2 into this? So of course you're going to get the same answer. Well, if it was a free response, I would work it out because there might be 4 points assigned to this, and 1 point might be showing this, 1 point might be showing this, 1 point might be your answer, 1 point might be your explanation of comparing it. On a multiple choice, it's just either you get the right answer or not. Okay, we're down to about 20 minutes. Is there any questions I can do on the board? Yeah, Ryan, what do you got?
Number
18? Okay, so for question 18, it wants us to talk about if this is continuous at x equals -3, and whether this says using the definition or not, you should be using the definition because that's the easiest thing. So there's no shortcut. You have to memorize the 3 parts to be to fit the definition of being continuous. You have to make sure that the point is there, that the point exists. So I'm going to plug -3 into this piecewise function. That would be into the bottom one because this is when x can equal -3. So if I try to plug -3 into 5, there's nowhere for the -3 to go, so it's just 5. But the point is that the point exists. That's one thing that has to happen to be continuous. Another thing is the limit has to exist. So I need to think about the limit as it approaches -3 from the left, and the limit as x approaches -3 from the right. So from the left, that would be x values that are slightly smaller than -3, which would be up here. And oops, let me rewrite f of x with factoring. Okay, so if you plug -3 into this, you get 0 over 0. So you're going to have to factor it, cancel, and then plug into what's left over to see that the left limit is -6. For the right limit, you should be picking a value slightly bigger than -3, but that still goes into the top one. It's this anytime x is not negative 3. So that includes values slightly smaller than negative 3 and also values slightly bigger than negative 3. But if I'm plugging negative 3 into the same exact thing, I'm still going to get the same thing, negative 6. Okay, and then the last part of the definition says that the limit has to equal the point. And I think that's not true here. I think those are not equal because I got 5 for the point and I got negative 6 for the limit. So it's not, but your justification needs to be at least this. You have to at least show that the limit's not the same as the point before you can say no.
So if you're doing one of these problems, you start doing it and then you find out it exists, so the first one's true,
Mm-hmm.
and then you start doing the limit from the left,
Mm-hmm.
and it's different already from the first one, could you just stop there and then write that?
Yep, you can stop the second you find something that's not true. If this didn't have a point, I would have stopped and said no, f of negative 3 doesn't exist. If this limit from the left didn't equal the right, I would stop and say no, it's not continuous because the limit from the left is this, the limit from the right is that, and they're not equal. But those two were true, so I had to go all the way to the third part of the definition on that one. But there's no shortcut for knowing the 3-part definition. You're going to be making the questions way harder, in fact, almost impossible, if you don't have that memorized. Okay, can I take another question or two? Okay, we still got a little bit of time, so I'm going to set one more timer, and I will bug you for questions one more time, but of course you guys are welcome to ask as you find stuff. Just for this class period?
Yeah.
Okay,
And
I've got some.
advisory. So,
Huh?
and advisory.
Yeah, that's fine. You can also, since this is an AP math class, you can check one out the whole year too to keep it home.
I've got one, I just it's at my house.
That's fine. You can borrow one of those and just put it back when you're done.
Thank you.
Okay, we are down to about 11 minutes here, actually about 10 minutes. So I said I'd give you one more chance. I had to make sure that I had time to answer your questions if you had some. So is there anything else I can help you with on the test review? Okay, if you do find anything in the next 10 minutes, obviously let me know. If you're in here during advisory, this is where you signed up for, then of course you can ask during advisory also. But a couple things to keep in mind here. Make sure you have those assignments ready to turn in, or better yet, turn them into Google Classroom so you don't forget them, lose them. If you have any late incomplete work, your last chance to get more points out of those is between now and the start of next Tuesday, not later in Tuesday, before we start our quiz on Tuesday. Again, I don't take questions on quiz day, so make sure that you try to come see me during advisory maybe. I don't know, I guess you would have already had to have signed up. Yeah.
So I'm just turning 11, 12 on Tuesday.
Probably 11, 12, and 13. I think you should probably have, I think there's one or two other assignments you should have done, but these are the ones that I'm going to stick with handing in this time.
You don't need to explain 2 from 22.
Is it continuous? Okay, so the point, there's definitely a point at 1, 2. What's the limit as x approaches 1? If you're trying to figure out if it's continuous, you need to be going through all 3 parts of the definition. So I would do the limit as x approaches 1 of this. You're going to have to do factoring and stuff. And you're going to get 2. Okay, so the point's at 2. It exists. The limit exists. It's at 2.
And then equals.
And the point equals the limit.
Oh, okay. Thank
So
you.
your answer needs to be yes, but your explanation needs to say all 3 of those things.
Awesome. Oh, okay. I understand now. I plugged it in instead of finding the limit.
Okay, yeah.
Thank you.
Okay, and again, I mentioned this at the start of class, but just giving you a little extra reminders here at the beginning. This quiz will end up going in as a 20-point major assignment, which is not that big of a deal at the end of the semester, but temporarily, it'll be your only major assignment. So it'll be 60% of your grade temporarily. We don't do test corrections. We don't do retakes. I don't think any of y'all should have been doing that much last year if you were a student here, but just a heads up. We do allow the final exam to replace a test grade, but you don't want to start off the semester with the test grade that you feel like needs to be replaced. So there is a second chance type of opportunity with the semester test, but again, you really want to start off as strong as possible. You might think this unit's hard, but you don't know Unit 2, Unit 3, Unit 4. You might end up thinking Unit 3 is harder. So try to aim for as best that you can for this quiz, obviously, and hopefully you won't feel like it's the one you need to aim to do a grade replacement on. And then finally, last piece of information, I guess, that I think should be a little bit of an incentive. Most of the time, at the end of the year for AB students, when we start reviewing for the AB test, or the AP test, limits is usually the topic that students feel the least comfortable with. It's not that limits are the hardest, it's just that most of these limit questions that we do show up in this first unit. Limits do trickle on throughout the year, but they don't show up very often. So it's not like you get to practice limits every single week and you just get better and better and better at them, kind of like we do with unit circle and pre-calculus. So by the time you roll into March, students often feel the least familiar with it because it's been the longest removed. So I say all of that to, if you really study this, and not just try to prepare for the quiz, but try to learn it well, that will be less of a concern for you at the end of the year. Okay, so feel free to go ahead and keep going there. You've got about 6 minutes, but if you would rather look at today's puzzle, I think I've got another one for you. You have to, all my classes are in different spots though, so did we do the Rubik's Cube race last time? Okay. All right, the next one I've got for you is a logic puzzle, and it's not the easiest logic puzzle I've ever seen, and it's a little hard to get started, but it is a very rewarding logic puzzle. So those of you that like logic puzzles, this is definitely one of the better ones I have ever seen. Based on the other classes though that I've seen or talked to with this about, a lot of people don't catch the what this is saying. So if you buy one hog, it costs $1. If you buy 2 hogs, it doesn't cost you $2, they cost you $2 each. So that would really be $4. If you buy 3 hogs, it's not $3, it's $3 each. So 3 hogs would be $9. So if you don't read that each part, it's kind of hard to get started. But the only hint I will give you, because I wouldn't want to give away too much of it anyway, is there is like a math equation or two. If you can represent this stuff, then what's left behind is not too bad. But for those of you that like these things, I will post the answer and solution video on Google Classroom. So feel free to watch that if you'd like to.
Can I see what Archie I think I have today?
You may. Not on your phone, on your Chromebooks. You've got Chromebooks. Or you can wait between classes, you can use your phone. Okay, you're down to about 2 minutes. So if you have any questions that would be fair to ask about the quiz next class, obviously I can't tell you what's on it, but if you have any directional questions about the quiz or what assignments are going to be turned in or late work stuff, anything you want to get cleared up, make sure you ask before you guys leave.
You said it's 20 points. How many, are there 20 problems on it, and do we have the whole class?
You won't have the whole class. It's hard to say how many questions because free response could be 3 parts or it could be 6 parts, so that changes. You should expect about 10 questions and a free response.
How long will we have to work on it?
You did not have to turn anything in today.
How long will we have to work on that quiz?
Roughly half a class, unless you have extended time. Most of the year, that's not true for the first couple, but most of the year we'll do 9 multiple choice and 1 free response for our big test. And then it just makes it a little more uniform, a little more standard.
This is entertaining for last. Last group for years. Oh, wait, this is country. Group trucks. Oh, that's good. The last.
Have a good day.